Today is Tuesday, March the 9th, 2021. This particular test for Northfork Electric, we're going to show the high voltage, low current part of the test. We have the previously described cabinet, and what we're going to do is, we've already gone through our connections. We have 120 between positions 1 and 3 to provide power to the board, to the bridge fan, and to the cabinet fan that is controlled through a thermostat. And here we have on positions 6, 7, and 8, and it's actually, we're using only 5 and 6. We're bringing in an additional, that's what we get, our SIC high, that's a 40-20 milliamps. Then we have on 7 and 8, that's a second 120 volts AC that controls the AC contactor, and it also controls relay K1 that in turn controls the soft start. Then we have the relay. Then here we have our emergency stop. We have the K2 relay, that it's the enable status relay that we could monitor or not. That will change the contacts, whether it's open or closed, as a function of the enable status. Then we have let me see if we have enable status, and then we have the temperature reading that we're not going to show in this particular video. We've shown it on the low voltage high current. And here we have our connections to our transducer. We're picking up the output. We are providing power, and then we have also, actually this is where we're bringing in the voltage from the bridge, and this is where we're picking up the 40-20 milliamps. And these are the connections from the line to the primary of the transformer, the secondary of the transformer. This is both the input and the output are protected, and here's where we distribute the 24 volts to the voltage transducer, to the current transducer, which we have out here. We don't have it. We have power, and we're not picking up any output on this particular test, and we will have the our wire, the connector wire, going to from the negative bus through here to our load to monitor our current. And that's basically it. We have our breaker, we have our fuses. So this part of the video, we're going to go ahead and get started by applying 120 volts. This is the 120 volts that provides power to the board, to the bridge fan, and to the cabinet fan. The cabinet fan's already on because of the location of the setting of the thermostat. This one will not come on probably because it's not going to get up to temperature, where if it hits in temperature where it could be 60 C, then the thermostat will close and the fans will turn on. And now that we have it here, I'm going to go ahead and ask Tony to bring in the line through the breaker. That's the 240. Notice that we got 240 here, but the contactor is not closed. So when we bring in the second 120, we're going to energize our AC contactor. This relay will turn on and the board will soft start. And what we got here is we have the voltage feedback that right now, because the module is not on, we don't have the 4 milliamps. We have the voltage before the contactor. We have our SIC high that it's already been set up to 20. I can bring this to 20 milliamps. And we have the DC output that it's 0 because the unit is indicated. We're going to be monitoring a couple of references from the board, test points, the A reference and the plus A output from the board. And we're going to look at the DC output across our resistive load. So I'm going to go ahead and so I have my 120, I have my contactor on, I have 14 milliamps of voltage because my output now is 313, I have it 20, and we notice that what we have now is we have our full output, or 315 on the load. So if I now bring in my emergency stop, I can see right there, it completely stopped, it inhibited. If I bring it back again, it's there. So I'm going to remove the 120 again from the contactor, and I'm going to go ahead and bring that 120 again, and we'll see how the output across the load will soft start. Here we go. Alright, so this is basically the end of this video, not showing the naval status or the temperature across the second thermostat, measuring the temperature of the heatsink. This is the end of this video.